Welcome to the post-class activity for the binomial distribution developed as part of the MT-StatPal project at Middle Tennessee State University. If you did the in-class activity for the binomial random variable, you dropped candies on paper plates to model a problem about nursing retention. 75% of nurses leave their job within the first year. If a hospital hires 10 new nurses, it would like to know what kind of nurse turnover numbers are to be expected. Let's let the random variable x be the number of nurses who leave after 1 year. We know that x is a binomial random variable because it counts the number of successes in a binomial experiment. A binomial experiment is a sequence of trials where the number of trials is fixed, each trial is independent, each trial has only 2 outcomes, and the probability of success doesn't change. In the nursing example, we have 10 trials since there are 10 nurses. We will assume that the nurses make their job decisions independently of each other. The 2 outcomes we are interested in are nurses leaving their job and not leaving their job, and the probability of one nurse making the decision to leave is 0.75. During the in-class activity, you saw this table and graph, which shows that the probability of exactly 6 nurses leaving the hospital is 0.146, or 14.6%. Let's talk about where the table came from. The formula for the probability of getting exactly x number of successes in n trials of a binomial experiment is this. Let's look at each piece of this formula separately. Notice the p raised to the x power. Because the trials are independent and the probability of getting 1 success is p, the probability of getting x successes is p times p times p x times, or p raised to the power x. Now look at the 1 minus p to the n minus x term. Because the probability of a success is p, the probability of a failure is 1 minus p. And because there are x successes and n total trials, there are n minus x failures. So the probability of n minus x failures is 1 minus p to the n minus x power. Finally, what about this ncx term? This is the number of ways to choose which trials are the successes and which are the failures. If we want to calculate the probability that exactly 6 nurses leave within the first year, we can use the formula, or we can use a graphing calculator. Press second vars to access the distributions menu. Scroll down to select Binom PDF. Then enter n, p, and x. For our example, n is 10, p is 0.75, and x is 6. The probability that exactly 6 nurses leave in the first year is 14.6%. What if we want the probability that no more than 6 nurses leave the first year? That is, what is the probability that the number of nurses who leave is less than or equal to 6? Finding this probability requires adding the probability that exactly 0 leave, exactly 1 leave, exactly 2 leave, etc., until we get to the probability that exactly 6 leave. There are a couple of ways to do this on your calculator. We will use this way. Select the Binom PDF choice and enter n and p as before. This time, though, instead of entering one number for x, we enter a whole list of numbers for x. 0, 1, 2, 3, 4, 5, and 6. You can enter a curly bracket by pressing second and the parentheses key. We want to store the output of this command in the list, so press Store and L1 to enter the output in the list L1. You can see the values in L1 that were stored there by our command. The first value, 9.5 times 10 to the negative 7, is the probability that x is 0. The second is the probability that x is 1, etc., until the last, which is the probability that x is 6. Notice it's 0.146. To sum these numbers, press Stat and choose the Calc menu. Select one var stats, then press second one for L1 and press Enter. The sum is the second item in the list. So the probability that no more than 6 nurses leave is 22.4%.